Welcome. Today we're going to look at projectiles at angles. I want to talk very briefly about the difference between horizontal projectiles and projectiles at angles. So I've drawn up here a couple of diagrams. The first, for a horizontal projectile that has a velocity, an initial velocity of v naught, given that v naught, we can find the component, the x component, it's just equal to v naught. And the initial y component is equal to 0. So there's no vertical velocity, no velocity in the y direction until after the projectile has left the edge of the cliff here and has begun to fall. And then its v naught accumulates in the downward direction, in the negative direction as it falls. And that's, of course, due to gravity. That differs from a projectile at an angle. At an angle, we have a v naught, just like we have over here, but it's not focused in only the x direction. There's both an x and a y component, which you can get with trigonometry using the sines and cosines. So given our v naught, the vx, that's the portion in the x direction, is v naught times the cosine of theta, and vy is v naught times the sine of theta. So the only real difference between the two is that in the horizontal case, we have no vertical component at all when we start, although we do at the end and anywhere in between. And here we always have a y component, a vertical component. These equations are exactly the same and could be used for horizontal motion if we wanted to, because the cosine of theta, if theta is 0 degrees, is just 1, which means that Vx is equal to V naught, just like it is here. The sine of theta, if the angle is 0, the sine of theta is 0. 0 times V naught would give 0 for Vy. In other words, it's the same. So you could use these equations for horizontal as well, and they really are the exact same equation. We've just gotten rid of the sines and cosines on this side because it's a special case where there's no vertical velocity because it starts off in only the horizontal direction. Now what I want you to do is copy down the equations that are in your notes, and when you're done copying down the equations, watch the other video where I derive all of the same equations we would use for horizontal projectiles, but for vertical projectiles.